Hello and welcome to the Data Centered Leadership Podcast. Today we have a really exciting guest. His name is Michael Krizmanic. He's an experienced software engineer who's transitioning into data science roles with his company.
Yeah, thanks for having me. I'm glad to help if I can. Okay, so I guess I don't have any regrets with the path I've taken to get where I'm at. So I guess maybe I'm lucky in that regard. Maybe a lot of people wish to do something different, but I was fortunate enough to have, just good friends that I talked to that sort of like me to make some good decisions at the time. So my particular major was actually in the School of Business, but it was called Operations and Information Management. It was business's take on technology.
Oh,
So
cool.
it's School of Business, yet a lot of tech exposure. So that meant graduating in 2002 with a degree like that. The dot-com bust had just happened. Technology jobs were few and far between. And those for like a business grad with no proven experience of any kind, it just wasn't really a good time. So for me, what I did then was I got every IT certificate to like get qualified for specific IT jobs, and then that it was like not a problem to get. Um, Basically, some school called New Horizon package called the Cyber Defender program. It was an A plus, Network plus, Security plus, MCSA, and CCNA certification. You get all five of those things over the course of a year. They have a test taking guarantee, so you pay them, they'll pay for your test as many times as you need. We got practice tests, all that stuff. The whole thing worked very well. Maybe a little expensive, but it was good to get the focus and the traction and get all that done. And then once that was done, jobs were pretty easy.
So you felt like the certifications were more valuable than the degree then?
No,
No?
not at all. No combination. Like the degree never goes away, right? You get a degree, that's something you've got for the rest of your life, and it always factors into everything you do forever. So yes, get that silly piece of paper, it matters. But then to get your foot in the door to prove that you've got something specific, to get a first job, I think the certificate helped a lot. Having the degree on top of it also helps in the interview process when you're talking about that sort of stuff.
Interesting.
So it's sort of like, okay, from their records, from their record keeper. Basically, get the sign off from the plan sponsor, get access to the data, invest for everybody unless they choose not to.
Okay.
So, yeah, so that was sort of I guess ProManage actually invented the managed account per the owners of the company. And now you see managed accounts often because it's a very common sense approach to managing retirement money. Most people just don't want to learn enough about investment to pick all their own funds. When you do nothing, good things should happen, not disastrous things.
Yeah, tons of testing has actually shown that it's better to just leave it alone like that too.
Yeah, and one of the that the company was making, they're always pushing for auto enrollment, automatic elections, and automatic increases in contributions at pay raise times. Just so that the person really doesn't have to do anything. They're just trapped into having a good life later when they don't realize it. But otherwise, okay, don't contribute to anything and then you retire. If you manage to ignore it your whole life, and I think some people out there will, you're going to be coming up short when you're trying to make ends meet, and you're going to have to just work a lot longer.
Cool.
So, yeah, So then I guess I enjoyed my time there. It was a small company. I started there, after college, and then, it was getting to a point where I knew that I could make a lot more money than, whatever percentage of starting college grad salary they wanted to keep throwing my way to keep me around longer. And so I basically became a mercenary. I made their site in PHP and actually hooked them up with a third party who would run simulations to see how likely they are to reach their retirement goals.
Wow.
I hooked up everything that works with all of that. I used it to just go for the next job because I knew there was a high demand in Chicago for PHP developers. So I'm like, all right, that's the next thing I'll pick up because it seems easy, high demand, no problem. That means the money will find me, so I'll find it. And sure enough, it worked. I've been making significantly more since then, and still been getting lots of raises, but now starting off of a better starting place. So I don't have regrets. And it's also like I'm finding that Pizza Hut's a good company to work for, where
So
I'm at now.
you've definitely been spending a lot of time like strategizing, looking at the job market and deciding what's the best thing to learn, and also spending time learning that as well.
Yeah, exactly. It's, if you're going to work in technology, it's a commitment to lifelong learning, whatever you want it to be. There's so many different nuanced paths out there. Find something that, you're passionate about and just keep asking why, and you'll find really cool things at the end of it.
Nice.
Yeah.
And you're interested in getting into more adding data analytics to your repertoire now?
Yeah, so okay, so basically my brush with the sense of science, I've ever heard about it. I was already working for the company Quick Order that ultimately got by Pizza Hut. The dev managers who came in, he was like the second one to have the job when I was there. I didn't go for the job at that point because I still felt like I was learning things in hindsight. Maybe that's a regret. Maybe I would have just gone for it back then, and who knows? Maybe I'd have a cooler title right now. But coulda, woulda, shoulda. It's fine. Um, the dev manager at the time, he goes, "Oh yeah, well, there's data scientists making $250,000 a year." He told me this after we got tasked as a company with integrating Google Analytics with the website, and it just wasn't really working well. So I just worked with the analytics people and just opened a dialogue and took an iterative approach, and we ultimately got it working exactly the way they wanted it, and everybody was happy. So it was after that he told me that I should start considering looking into data science. So I mean, I kind of took a cursory look. I was always interested in the field, but every time I turn up a lot of the rocks, it all seems basic. Um, at first, it's like basic and magic, the two sides of the coin. Like what they'll teach you is basic, but when you see the cool things happen as a result of all those basic models, then it looks almost like magic. So for it looking like magic, that's what keeps me interested. I want to impress myself because I know how to build just about everything. But then you start seeing these models do really cool things that just defy traditional programming. That's I was very excited to find that design space and start doing things in there.
Nice.
Yeah, and all of the how-to is just online.
So are you saying it seems basic because you've built so much, like in the ages of older languages and older frameworks, and now the software is working at such a high level, it just like seems really basic to implement?
Maybe in a way. Like in taking one of the classes online, basically, oh, if you want to be a data scientist, just get good at Tableau, and then you're halfway there. Because then they go on to like all the communication and all the aspects. If you hear what's a great data scientist, the vast majority of it isn't really about data science in particular. It's always about communication, teamwork, you know, just being that person to rally people together around a cause. That sort of thing is always sort of what they seem to be looking for out there. And that's not stuff that's stuck in the data science field. That's stuff that's in like all field industry. And you need to have the ability to communicate and just give people what they want, even when they don't always know what they want.
Yeah.
Sometimes you gotta give them what they meant, even though they didn't tell you exactly what they meant. Yeah, like just yeah, and it's like looking it up online. Weird combination of like that's too easy. Then some of it's like seemingly impossible. You get these mathematical formulas. I would so much rather see Python code than a long mathematic formula that does exactly the same thing. I look at the math Greek, and I'm like, well, it's kind of like looking at Greek, because kind of is. Okay, I know that the big sum is a four. You're adding everything up there, and but sometimes I don't know. I still get a little intimidated by the giant math formulas, even though like I destroyed math all the way up through everything I've ever taken and had no problem with any of it. Now it's like the higher level stuff. Okay, just not comfortable translating that into what it actually means.
I know that feeling.
I'm sort of more of a practical approach. Like like now I know, like, okay, so I've got maybe a question for you on this one. This one's kind of interesting to me. Like, all right, when you look at older techniques, like, your regressions, your logistic regressions, all those sorts of things where you're just categorizing data, right? All these techniques that have served mankind very well up until this point. But now we've got compute, plenty of it, and now we've also got like TensorFlow and open source neural network packages. It seems to me that a shallow neural net can just blow away the need for basically most older algorithms, because it'll figure out the linearities and non-linearities that those are designed to find in a more intelligent way. This is just a little bit dumber with a little bit more power, but the power is cheap, so maybe that's okay. Maybe that suffices.
I think that's no. I don't know about that. Like I've looked into well, first of all, shallow is really I think you have to be more specific about that. What's shallow versus what's deep? I would think a deep net could solve everything, but maybe not a shallow net. Even then, the deep net, you have to use one that's like already been built by somebody else. And because, like, for instance, I took the Andrew Ng machine learning course on Coursera, and everything just works so nicely when you're going through all their little tutorials and getting things implemented the way they tell you to. But then when they give you one assignment where you're supposed to like build your own architecture, actually the way that you build the architecture has a massive influence on the success. And like, I tried 20 different iterations of network architectures and they all gave horrible performance. And then finally I just like looked up what somebody else said and they modeled it off of something in the literature, and then bam, I was getting killer performance, like above 90% again. Whereas with all these, and so that's one thing I'd say is, like with a caveat, maybe you can get a neural network to work on anything if you're patient and you just use something from literature and tweak it as little as possible on your to fit your problem.
Okay, well, do you want an example where I kind of did exactly that, and it seems to be performing very well?
Oh, you
I don't know what better is. I sure have, of course. Nice. So this is one of the most things I'm most proud of with my whole little time in data science. It's if somebody basically fills in the tech form on the .com website, it used to be that there's like a team of people reading it, a small team. It used to be just one guy for a little while, and he just get through as much as he can.
Wow.
And then like a few items are actionable. The vast majority are just not. So what I did was I took a bag of words model out of the literature, threw out the naive Bayes formula, and plopped a neural network in the middle. And sure enough, worked just fine. It will do basically now, like, assuming you get good training data. So basically all I had to do is take that, okay, the n least common words in the corpus that can be made of these incoming flood of email, if I believe that the word used actually are predictive of the categories assigned, which I think they are. People say I can't find my address, it's probably about localization. The store ran out of this, it's probably out of order, out of product, things like that. So as long as that relationship is true, I mean, it seems to me that if you've got like a handful of dependent variables and some independent variables you want to predict, whether it's a categorizer or whatever that might be, the neural network it's fine, because as long as the data is good and consistent,
Nice.
There might be a better model, but like on this one, we the outcome has been 70% of stuff that's irrelevant, it's for anyway. This model has been very good at picking up the irrelevant and then getting rid of the 80% that's going to waste most of your time, then gets you looking at that other 20%. And we've had roughly, I believe it was 10 times the actionable items come out of that system from before having the system.
Wow, so that's incredible.
So the guy would spend a day, he'd have about 3 tickets to do something. Now it's more like 30 tickets. 30 cases have been reviewed. Maybe it's a handful of tickets that lead up to those 30 cases, but more cases get reviewed to take action on.
That's great. So does that you did that in Python, or are you running the neural network on a GPU?
No, Python and CPU. I like
Oh,
to make the whole world mad. The whole industry is like laughing at me at the way I'm doing it, but it's working and it's practical. So like I'm liking it. I tried TensorFlow 2 on my Blue. It could not work. The same exact model with TensorFlow 1 and regular Keras instead of TensorFlow 2 and Keras inside. The
hmm.
same model, uh, fine. Like a couple, like, train it in 5-10 minutes, can execute it in a matter of a couple seconds. Perfectly acceptable.
Nice.
Put it in TensorFlow 2, and basically the ETA just keeps going up. I'm assuming never finish.
Weird. How
Yeah.
how did you decide what neural network architecture to use?
So that's kind of interesting. So there's this data science competition out there called Numer, Numer.ai.
Hmm.
And what they do is basically they've got the entire stock market encoded into a bunch of hashes with a bunch of features on the hashes, and they've cleaned the data. So basically, they've done all the pre-processing work, the feature selection, very about this data, hiding it from me so I can't just trade on it. So they've encrypted this data, they present it to the public, put it out there as a data science competition. So basically what I did was I effectively brute forced APIs to learn how to tune the network the way I wanted it to work. So like I've got a limited set of data. They've got a holdout data set that they're going to judge my data on. So basically I just made loops and kept like making new architectures, just, like read what I can on the internet, get some ideas for theoretical limits in different directions, and then just see what works, and then just keep doing like running it over and over and over again, and like my own version of grid search basically. With the thing that would work would be have it output at the end one what the model was scored at by the competition, and two what's the architecture that went into it. So then at the end I just take all the architecture as a CSV, throw it in the Tableau, look for pictures, start pulling out what seems to be working to not be working. Um, at that point where for these problems, I like ultimately like, okay, you've got a number of input nodes. I like about 2/3 of the input as the first hidden layer, and then about maybe 1/3 of that remaining is a second layer, and then an output. And then, it's just trying these things, and it seems more art than science to the vast majority of the world. But you know what? Those seem to sometimes there's a little bit, maybe it's repetitive luck or something. It could be, like maybe the 10 times I happen to pick this, they all worked pretty well. But when I start pulling out things that work, I just gravitate towards those and let the other ones die off and just tweak in other ways and see, what the best I can do on it is.
Awesome. So
So
you set up some auto machine learning then. You created your own auto ML code and
I suppose
visualized
I
it.
did. Yeah, because really I'm just writing code to like, all right, I've got my way of configuring a network. I just set that up as a line. So I set up a whole bunch of lines, tweak them as is, let the computer run through them, and then at the end when there's output, I analyze the output and use a machine to do that. But I suppose there'd be a way to throw a machine at that and get all super meta with it.
Wow, cool. Sounds like you're
Yeah.
picking everything up really fast. That's
Yeah, I mean,
impressive.
I'm just good with numbers and that sort of stuff. It's just you know, we've all got gifts and things we're good at and things we're bad at. Numbers I'm really good at. There's a lot of things I'm bad at.
Cool.
Yeah.
Hmm.
So that's most of what I've done with data science. At Numerai competition, it was like a heavy question, but like after doing the math, I'm like, oh wow, with just this level of model, I can bet on it and actually kind of win. Oh yeah, they also pay you for this too. Like
Nice.
if your model beats the average, yeah, exactly, they'll pay you on it. It's like the weirdest gambling in the world, like as far as I can tell. You're gambling on your model's success, and if you bet on your model, they are going to use it in production to influence the way they trade for their hedge fund. But if you're wrong, they're going to burn the crypto that you staked to submit. But if you're right, you get whatever you staked back. You get paid on top of that, and you get paid in other ways, and you get the reputation. And over time, if you're right more than you're wrong, you're gonna be profitable.
Wow.
It's like gambling with a weighted coin, kind of. It's like you kind of always win a little bit if your model's good enough. Feeling pretty good about my next model. Took me a few days to find one that nothing seems to beat. So in a way, I'm wondering if I'm just using their own confirmation bias against them. Basically, it's like they've got in their mind something that works, and they're judging everybody else based on whatever's in their mind about something that works. So I use their judgment to pick my model. So effectively, I'm letting them help select my model. And so they might as well have just done it themselves in the first place, in one way of looking at it. But I don't know. Seems to work, and it seems to be a good model. And if, seems like a problem with like an infinite number times an infinite number of answers, and there's some really good ones out there, and I guess a lot of people are going to be looking for them. And the people who are winning these things consistently, I really want to know what they're like the top winners of something like this, because simple neural net doesn't seem to get all the way there, but I have been in the 98th percentile a couple times.
Nice.
So it has potential to have really good weeks, but some people are doing it consistently, so there must be something more to it than that.
Huh. Cool. Well, thanks for sharing. That's pretty inspiring. Makes me want to study harder and think bigger with respect to the machine learning and data science.
Yeah, it seems like there's a lot out there. There seems to be no shortage of opportunity. I think it was a New York Times article that I read shortly after Sam pointed me towards, hey, why don't you look into data science? There was an article basically stating that by around now, like it's a dated article, so by around our current landscape where we are now, there should be hundreds of thousands of data science jobs that are just unfillable because there aren't enough qualified people. I guess they extrapolated back then based off the sheer volume of data out there and how, like, the big data problem, it's growing exponentially.
Yeah.
We've got, I don't know, like how many hundreds of thousands or millions of times the total data than we did at like the year 2000.
Wow.
Like it's so exponential. If you look at all of mankind's data, and then just look at where it is, cell phones tracking our every move, looking at every purchase, every server that serves up every website has its log with 10,000 things that no one will ever read. There's basically so many sources of data that no one will ever read or ever pay attention to because there isn't enough attention bandwidth on this planet.
Yeah.
So machine learning is the shortcut through a lot of that darkness.
Cool. So do you think that they extrapolated correctly based on the jobs searching you've been doing, or based on what you've seen?
I haven't really been looking. I've just been studying because I'm interested enough at my current job to have like a nearly insurmountable problem to fix.
Awesome.
So I love having one of those, but maybe when I'm done with this one, maybe I'll get bored and start looking and see what the whole landscape holds. But for now, I'm just enjoying the current job.
Nice. Yeah, it sounds about right though. 100. I think there are around like 50 to 100,000 unfilled data science jobs.
Right, just no one's qualified enough. Like that seems to be the thing, or maybe no one can prove that they're qualified enough. If those are different things.
Yeah, well, I mean, now everybody wants to be a data scientist, and every company wants a unicorn data scientist, and it's there's a lot to learn out there. There's a lot of information. I mean, even just the data science analytics knowledge is, it seems hard to decide what to focus the studies on, or at least it did when I first got into it. I mean, personally, I put all my efforts into Python. I've kind of avoided Tableau and R. I know those are those seem like pretty popular packages.
Yeah, I mean, Tableau is pretty cool for like turning a CSV into something visual that's highly dimensional. Like I found you can get 5 dimensions on paper pretty easily. That's x-axis, y-axis, size, shape, color. It's an easy way to get 5 dimensions on a 2D grid. Tableau is outstanding for, like, Tableau actually showed me that. I didn't even think about it that way until I just played with Tableau a little bit. But yeah, Python, I got that recommended to me while I was still at that first job at ProManage, maybe a year or two into there.
Oh,
I was
wow.
just out at a bar with some friends in the industry. Someone international, it was somebody from, I think they were from France, someone from overseas. I was just kind of throwing the question out there. Okay, what's the one good thing to learn? He's like, Python. So after that, I started messing with Python, and I got to admit, after a good decade or so playing with it, whatever you can imagine for a computer algorithm that needs to be solved, someone's already got a library for it in Python. It's very tested. It works great. All you got to do is just open up and switch a couple parameters, and somebody's done all the hard work pretty much every time. That levering the community to, like, basically, just use all these tools there so that you can accomplish whatever needs to be accomplished super cost efficient way. I think Python is amazing for that.
Oh, okay. I see. Based on your LinkedIn and your initial description of what you've done, I thought that you mostly knew PHP. Now I understand why it was so easy for you to build an auto machine learning package in Python, because you've already been studying it for like over 10 years. Okay.
Right, but like actual studying of Python itself, that was a $20 class I took on that a decade ago. Easy. It's simple.
Wow.
Yeah, I mean, like, yeah, Python is just, it can do everything.
Yeah.
Just not necessarily so it's not for production always. For
Oh, really?
anything that supports production in any way, you can get there. You can build your pipelines. Like say you're building like a world-class website and you want a bulletproof pipeline to get the code from A to B with like all the transformations to be done perfectly. Your pipeline could all be Python. It doesn't matter if it takes 10 seconds or 25 seconds in a pipeline. If you're just like, if you're off with the critical path, if there's no one's attention is in between, is waiting for the script to finish,
Yeah.
Python can do anything. But if someone's staring at the screen waiting for the widget to stop turning or something like that, Python might be a little slow for some bigger tasks.
Interesting.
Yeah.
Cool. Well, thanks for sharing, Mike.
Yeah. Yeah, happy to. So yeah, I mean, maybe in terms of like a toolkit to maybe use some deep learning with Python and everything.
Yeah.
Here's one thing that like I find really effective for communication and everything with coworkers and whatnot.
Okay.
So when I built this system, when I built the system for my coworker to basically amplify his ability to read email, we have to do there's a few key things that have to take place. Like, one, he has to be able to build training data. I'm not going to sit there and train it. I want him to train it.
Yeah.
So how do you come up with a common communication language from like more of an analyst type person to a programmer type person to a database and all these things? What's an easy way to get data around? And that would be Excel. Everybody uses Excel. Take the best business people you know, they might be like, what are you talking about with Python? Excel is it every day. They're comfortable with it.
Yeah.
Everyone in finance uses Excel. Everyone knows Excel. So if you use Python to write to Excel to make worksheets that coworkers can fill out. You can even do features like add the drop down so that they have a finite number of labels to choose from and things like that. All that's doable and exposed to Python. Then basically you can use Python as Excel as the GUI that you use to communicate big data around, or just smallish data or whatever size data with different people who don't have to be as technical.
Good idea.
So basically, yeah, use Excel to have your coworkers train the machine that they don't want to understand how to train.
Nice.
Yeah.
Cool. So what from what you've been learning about machine learning like about the technology recently. What trends or what topics excite you most for the future?
Deep learning.
Yeah.
Deep learning is my favorite one. Yeah, I mean that goes right back to this 2016 DevCon visit. I was there. It was like in Chicago, March 2016, give or take. And Google was really excited because they just unveiled TensorFlow onto the world, first quarter of 2016. So I was there for sort of like here's what we did with TensorFlow. Watching their demonstration on what they did with TensorFlow, my mouth was hanging open, like almost on the floor. It's like, I need to know what this is and how to make it do things like that. Just
Nice.
the output that you can produce with that package is just like, it was magic. Basically they're talking about how, oh yeah, we got this thing called TensorFlow. We run 60 kajillion servers and 17 continents, and we have 20 billion miles of cable, and there's all these like absurd stats that I'm obviously exaggerating on. And they're like, yeah, and what we did was basically we had TensorFlow learn the demands of infrastructure, and then just, yeah, basically have the machines themselves down and spin them up as they need to once everything's learned how to do it. Oh, it's about, just pull up the graph of where their expenses and lost compute power went and everything like that. And the charts were just outstanding. They saved a freaking fortune just by having TensorFlow decide, okay, you need more machines. Okay, we need to shut down some machines. So once I saw it was capable of that, I knew that there's a magic design space here and things like that is just sort of like open wild. You can do anything with all of these things, like from looking at packets go by from a security perspective to like, marketing, targeting the right person for the right ad. There's just so many obvious, to even destroying democracy and getting people elected who wouldn't have gotten the votes otherwise, probably, had they not bought enough votes in targeted markets at just the right people getting just the right message at just the right time.
So amazing.
Even Brexit was like attributed to Cambridge Analytica, the first that also helped American politics get where it is now. They basically broke democracy. There was a whole TED Talk on it. It was a great TED Talk.
It's pretty mind-blowing, yeah.
This is going to be something. What's that?
It's mind-blowing.
It is, right? This may have broken democracy. The way that the speaker laid it out in the TED Talk was basically that in Britain, it's very clear that you can only spend X amount of dollars to influence a political vote one way or the other. Facebook, being an American entity, didn't have to report anything to the British government, so of course they opted not to. And then some wealthy pro-Brexiters made sure that they bought plenty of targeted ads at just the right time to just the right people with just the right problem and just the right wording to make them be like, yeah, you know what, this Brexit is a terrific idea. And they probably weren't even that informed about it to begin with. They just got the right feeling at the right time out of a person and just exploited everything with it.
Yeah.
So I believe that is in our future, more of like society, one, opening their eyes to it. That's happening. And two, that's be something that they're going to have to take in politics and democracy moving forward, the ability to influence vote like that. It's just it's an interesting world that we're walking into, and the science is going to power both sides of it.
Mm-hmm. Yeah, it's really feels good to be working on it. It makes it it definitely gives me motivation to work harder on it, so we can be a part of that. The power.
Yeah, you've already got a PhD with that, right?
It wasn't in AI.
Is your PhD in data science?
It was in material science. So I've been studying data science like on the side for the last 6 years. So yeah. So I mean I know a little bit about analytics and statistics and Python like, so I guess I've been doing Python for about 6 years, about half time now.
Mm-hmm.
Um, so yeah, I still have a long way to go, but I recently got a job where I get to use more Python and more coding. So it's I think it's made it easier to study more and to especially to apply what I study. That's the real thing. Like I feel like I think I have more freedom now to apply what I'm studying, and when you apply it to something like they're like for instance what they were saying at the data science conference, like making the passion project, or if you have a job where you can apply it, that's when you really actually learn this stuff. That's what reinforces it. When you just take the online classes like I was doing for the last few years and you don't do much application of it, it just kind of fades out. Or yeah, I mean I would definitely say that it starts with knowing the fundamental basics of the language. Like I learned Python just by kind of like I got some codes from a national lab. That's kind of what got me excited about Python was they had some really good data uh, processing codes at the national lab. And I realized Python was about as good as MATLAB and free. And then I started learning about all the packages and all the machine learning stuff. And now more recently, I've learned some of the basics of the Python language, and it's just like, whoa, it's amazing. I was using Python the way I was before, like a MATLAB coder. And now that I know how Python really works, it's like so much easier and more fun to code in Python.
That's cool. That's good. Yeah, it's a very powerful lever. So I mean, I can never say that learning more Python is a bad idea to anyone. It's a good thing. Yeah. So yeah, for me also, data science has always been sort of a nebulous term. I've always, just kind of wondered about it. Like without data, there is literally no science at all. All scientists must be a data scientist at some level. So the question, I guess, becomes when does it become a discipline in and of itself, and when is it just the fundamental basics of anything called science?
That's true. Yeah, that's an interest. Yeah, that's a really fundamental way to describe it. And that was one thing that was nice about the conference, the Data Science Go conference, was that we, some of the more experienced, like the senior data scientist, John Peach, when he was describing the data science method, he really was like he was really putting extra emphasis on testing things like from a statistical perspective, like in a scientific manner, above all. And that does seem like the most fundamental tenet of data science. But it's funny because like none of the jobs ask for that. It's more like what language do you know?
Right, because it's really it's really hard to hire people. As I've always been saying, like anyone who's been in a hiring position has just been bitten once or twice. Just like, man, why didn't I ask that question? Or like something. The false positives are probably worse than the false negatives because the false positives you got to deal with for a while. So like when you hire someone that probably shouldn't have been hired, it's not good for anybody. So I mean, like one of the filters is okay, what technologies do you know? Like just throw out the laundry list and like, okay, yeah, we think you're probably gonna do whatever the job is provided in those technologies. It's one strategy. I don't know. I'm still looking for that really good one. I've tried all kinds of things and gotten all kinds of results.
Oh, you mean with making? Oh, so you have a lot of experience making job postings and hiring people and.
No, okay. So I was never the job posting maker. I was the interview that you're probably not going to get past. So I was like the one who was like gonna really give you a hard time to get past it. So like one of the things I did was I made this like really hard PHP test just by going to HackerRank, taking the absolute worst string problem that they had, switching it to PHP, my other PHP guys with, you do this, how does this work, right? I'm talking it through like, yeah, this is pretty tough. And we just like flip that on to people like, all right, well, people like you, and I just want to see if you can just solve this one problem. And let's do it as if we were like working in a ticketed working environment. I'll play the role of project manager. Ask me anything. Like, here's the problem. Ask me anything that I can answer to clarify for you. like maybe the wording isn't great. If there's any like nuances, you have questions on it. So let people have that and see if they can get past it in about like an hour to an hour and a half. And no one ever got past it, except for one guy who got past it. And man, is he a damn good programmer. But, he doesn't get along with everyone very easily. So, like, there's always trade-offs. So, like, the point is you can't really focus on one attribute too hard. You've got to, like, really find the well-rounded person that there just really is no good formula to do,
That's where the college comes in a little bit.
Right. Exactly. And it's like a hard, insurmountable thing sometimes when you're out there starting your career and like figuring out what you want to do. But also it's your gray area to work with if you can flip it and make it positive and just like, because truth be told, the will and ability to learn is worth so much more than having technology in your past. That if you demonstrate that you're into it and you're going to learn more, and you see it as like an ongoing learning experience, I think you can probably break through some of that gray area,
Yeah.
Because it's great for the job seeker and it's great for the job provider too. So use the gray to your advantage if you can.
Yeah. That's.
Really don't hear too much like that.
What?
It seems like you don't hear too much advice like that. Like, just use the terrain to your advantage. There's always something going on that you can use to your advantage.
Yeah, that's.
It doesn't hurt to do that.
No, that's actually. I think that's the way I usually operate. I mean, but it's a.
Yeah, that's
but to hear somebody recommend
the way
it.
to do it to get results.
Yeah.
Yeah. If you're not doing that, you're losing out on some of life's greatest rewards because there's so much uncertainty everywhere, especially the higher up you go in an organization, so much uncertainty. Just getting a grip on that uncertainty is what a lot of people want. And if you could give them a little bit of grip on that, sometimes that will open the right door at the right time.
Cool. All right. Well, great. That's thanks for your insights. It's been
You're
really
welcome.
helpful.
Thanks for listening.